we can start our discussion of other software engineering areas of concern by talking about testing and talking about software quality. When we talk about the quality of anything, in some sense, from the user's point of view, the person who is the client for that thing, what they want to know is, does it do what they need it to do? So sometimes you'll see this called fitness for use when you look at those long end user license agreements. And this means that it has business value for both the customer and the manufacturer. The value for the customer is obvious. They bought it because they need to solve some problem. The value for the business is that they get to sell it. So unless both sides of that equation work, the software is in some sense short on quality. And with that definition, quality assurance is sort of trivially defined as what are the processes and standards you have in place to make sure that that happens. So software quality from the customer's point of view, it works. It does what it's supposed to do. It gets the right answer. It doesn't crash. It doesn't have a lot of annoying bugs. But it also means for the developer, because again, change is a fact of life, customers' expectations will evolve over time. So the ability for the developers to be able to enhance and maintain and add features to that software, to have it have a long lifetime, right? To keep that customer happy and in your client base for a long time, that's something that accrues to the developer. So it is not the case that once you've shipped the software, you're done. You need to be in a position to continue to add value all the time by enhancing it, which is where the agile methodologies come in. In that sense, we can say that software QA is not just about testing and finding bugs. It's about making sure that both sides of that quality equation are being satisfied and that you've got processes in place that are actually doing this. And by the way, in modern development, even in companies that are only recent converts, I should say, to Agile, QA is everyone's responsibility. So in the sort of bad old days of software, there would be developers who would sort of write the code, and then they would, quote unquote, throw it over the wall to the QA team who would test it and find bugs. That's generally not how it's done anymore. In fact, a few years ago, I read this interesting statistic. Microsoft used to boast, and we're talking sort of back in the 90s, that they had a ratio of about 1-to-1 for software testers and software developers. So kind of for every person writing code, there was somebody who was like the tester or the QA person for that developer's code. And I remember talking to someone at Google and asking, well, what's the ratio at Google? People who work in software testing as compared to software developers. And it was like 1 or 2 orders of magnitude less. It was like one software testing person for every several dozen or even couple of hundred developers. But that's because in Agile, the developers are doing their own testing. The people who work in software testing are not writing tests for your code. They're writing the tools that help people test their own code. They're writing continuous integration frameworks. They're writing stub libraries. A lot of the things we'll talk about when we talk about testing. We're going to talk a lot about testing in this class. So in modern Agile development, you are your own tester, but there's a group of people whose job it is to produce the tools to let you do that. And that's really a big change from the older model where the developers were not, by and large, were not responsible for doing the majority of their own testing. In hardware and software, we talk about two related but different terms in testing, verification and validation. Basically, verification asks, did you build the thing right? In other words, if there's a specification of what it should do, does it in fact do those things correctly? Validation is, did you build the right thing? Did you build the thing that does what the customer wants? And maybe it's because the specification was not well written and it doesn't do what the customer wants for that reason. Or maybe the specification was right, but the customer has changed their minds, because customers will do that. So for the most part, if you come from the hardware world, verification tends to be more important. You're designing a complex hardware artifact. You have a spec that is very clear. You want to make sure that the thing you're actually producing has met the spec. If you're in the software world, it is at least as important to ask, does this solve the problem the customer cares about? Because solving an unnecessary problem really well is not a great business proposition. So how do we make sure that we actually achieve both of these things in software? Testing, which we're going to do extensively in this course, and we have very much to say about, and formal methods, which are basically ways to prove formally that certain kinds of problems cannot occur. Formal methods are becoming, I think, increasingly interesting in the area of software verification, not so much validation, because validation almost by definition depends on a dialogue with the customer. But formal methods have made a lot of inroads in software testing. We will talk sort of in passing about a lot of them. And in some sense, it's because it's still the case that the universe of problems that they can really solve, as compared to the overall task of software verification, is still relatively small. So I don't see testing becoming less important anytime soon. Of course, exhaustive testing is infeasible. You can't prove the absence of bugs with testing. The best you can do is hope to prove the presence of bugs because your test will find some bugs. But you can do some things to break the problem down. You can divide and conquer. You can think about different levels of testing in the sense of levels of abstraction, and you don't repeat tests at higher levels that have already been performed by lower levels. And we'll have something to say about coverage, which is basically many different ways of talking about what fraction of behaviors of the system are actually being exercised when you run all of your tests. So what do we mean by testing and levels? You probably have seen these in sort of introductory programming classes. A unit test, where you call a single method and you see that it does what was expected, whether it returns the right answer or it has a certain side effect. But once you get away from simple unit tests, there's many more interesting things you can test. For example, most interesting behaviors in software are not just calling one function. It's an ensemble of functions that are working together. So you need to find ways to test small groups of functions that perform some well-defined task together. We'll usually call that module testing or maybe functional testing. There's also integration tests, different components of the system that have to communicate with each other. And is the communication across those interfaces happening in the right way? Which is a different question than asking whether internally are those subsystems doing the right thing, right? Those things can be tested separately. So one question is, if my unit calls your unit, you're expecting that my request is going to have a certain format, that there might be certain constraints about what I'm allowed to ask for. I'm expecting that the response is going to take one of several formats, or if there's an error, I'm expecting a particular behavior to demonstrate that error. So that can be tested separately from the question of whether your unit is internally doing the right thing and my unit is internally doing the right thing. And finally, there's what's usually called a system test or acceptance test. This basically means the integration tests exhibit correct behavior. Now the question is, do they actually do what the customer said? And what we're going to learn is that this is not just about putting the system in front of the customer and having them use it, which we'll certainly do. But it turns out you can also automate a lot of what the customer does. You can essentially script the customer's behaviors and use them as part of the documentation of what the system is supposed to do. So we're going to show you some really cool tools that help you do all of those things.